Good morning, everyone. Good morning, class. I am Ma'am Yana and welcome to our science class. Today, we are going to discuss how is the center of gravity related to equilibrium. As we proceed with our lesson, we aim to achieve the following learning objectives. At the end of the lesson, the students should be able to identify the three states of equilibrium of an object and their relation to the location of its center of gravity. Perform experiment to differentiate the three states of equilibrium of an object and appreciate the significance of the center of gravity in maintaining equilibrium and how it applies to real life or real world situations. Also, as we go through with our discussion, we have here our mini dictionary that will help you to understand some unfamiliar words. Unlocking difficulties. Gravity. It is a force that pulls objects toward each other. Equilibrium. When an object is balanced and not moving because the forces acting on it are equal and opposite. Center of gravity. The point in a body or object where all the mass appears to be located. Pivot point. Central point on which something balances. Restoring forces. A force that tends to restore a system to equilibrium after displacement. Displacing force, a force that displaces an object from its original position and prevents it from going back. We have three states of equilibrium, and these are stable, unstable, and neutral. Let's start first with stable equilibrium. In stable equilibrium, a body is said to be in stable equilibrium if after a slight tilt, it returns to its original position. Its center of gravity is at the lowest position, and when it's tilted, its center of gravity or COG rises and returns as long as the center of gravity acts through the base. As shown in the figure, the marble in the bowl returns to the bottom after being displaced from its equilibrium position. It is similar to the pencil that can stand upright on its flat end, and this object is said to be in stable equilibrium, wherein any small displacement from an equilibrium position results in a force that tends to return the object to its original position. And we also have here some of the examples of stable equilibrium. A four-wheels car, a traffic cone, and an Eiffel Tower. As you can see, these three samples showed a wide base. Another type of equilibrium is unstable equilibrium, wherein it is a body that is said to be in unstable equilibrium if a body does not return to its previous original position when set free after a slight tilt. The center of gravity of the body is at its highest position. As the body tips over, its center of gravity moves toward its lowest position or lower position and does not return to its original position. We also have here some of the example of unstable equilibrium. So as you can observe, its base is narrow compared to stable equilibrium's sample, which has a wide base. And the last type of equilibrium is the neutral equilibrium. It is a body which remains to its new position when disturbed from its previous position, and it is said to be in a state of neutral equilibrium. So as you can see in the figure, it shows the different types of equilibrium. So the first figure on the left side shows a stable equilibrium, wherein it is a cone standing on its base and it returns to original position after a slight disturbance. And second one is a cone on its tip. On the middle figure is in unstable equilibrium and it tips easily when disturbed compared to the first figure. On the other hand, a cone lying on its side is in neutral equilibrium because it stays in place without moving further or returning to its original position. But it can be rolled from side to side. And these are examples of how an object's center of gravity affects its equilibrium. To sum up everything, again, equilibrium have three states, and these are stable, unstable, and neutral. Stable is the result and a force that tends to return the object to its original position, while unstable is a result of force that cannot return to its original position. And lastly, neutral equilibrium is when an object remains balanced in its new position after being slightly moved, or it can be rolled from one side to another. Now, I will show you two different image, and I will ask you, who can balance wall among the two of them? Of course, the sumo wrestler will balance better than skinny man lifting one foot. Here's why, based on center of gravity and equilibrium. The sumo wrestler has a lower center of gravity because of their wide stance and heavy build. A wider base of support or feet spread apart makes them more stable. Their center of gravity remains within the base of support, ensuring better equilibrium. On the other hand, the skinny man lifting one foot reduces the base of support, making balance more difficult. Their center of gravity shifts, and if it moves outside their base of support, or the one foot on the ground, they will lose balance. And being skinny doesn't necessarily improve balance. It all depends on the body posture and base of support. So to conclude, the sumo wrestlers' lower center of gravity and wide base of support give them better balance and stability compared to the skinny man on one foot. Just always remember, class, in the relationship of center of gravity and equilibrium, that a heavy and wide-based body is more stable than a light and narrow-based body. All of your learnings or knowledge gained from this discussion can be applied in real-life situation, in architecture and engineering, in sports and physical activities, furniture and product design, everyday life, transportation safety, medical applications, and gaming and entertainment. So thank you so much, class, for listening, and I hope that you learned a lot from our discussion.